Imagine witnessing an announcement that could forever change the world of technology. A company claims to have created a device that defies the very limits of science, based on a particle theorized almost a century ago and never directly observed. It might sound like the prologue of a science fiction novel, but it is reality. Microsoft has unveiled Majorana 1, a quantum chip that promises to revolutionize the field of advanced computing. Is this a groundbreaking breakthrough or just a clever marketing strategy? The scientific and technological community is divided between enthusiasm and skepticism. But to fully understand the scope of this innovation, we must first dive into the heart of quantum computing. It all starts with the concept of quantum computers. The traditional computers we use every day operate using bits, units of information that can take on only two states, on or off, 0 or 1. This binary system has enabled the construction of the entire digital world, but it has its limitations. As problems to be solved become more complex, classical computers must analyze billions of combinations one at a time, significantly slowing down processes. Imagine trying to find the exit of a gigantic maze. A classical computer would test each path one by one, whereas a quantum computer would explore them all simultaneously. This is possible thanks to qubits, units of quantum information that, unlike bits, can exist in a superposition of states. It is like flipping a coin and, while it is in the air, considering it to be both heads and tails at the same time. Another key concept is entanglement, a phenomenon where two qubits, even if separated by vast distances, remain connected so that the state of one instantly influences the other. This allows quantum computers to process information in ways that challenge our classical intuition. The problem is that qubits are incredibly delicate. Even the slightest interference can destroy their quantum properties, causing errors. This is where Majorana 1 comes into play. Microsoft claims to have created a new type of qubit called a topological qubit, based on a very particular particle theorized by the Italian physicist Ettore Majorana. This particle is believed to have a unique property. It would be its own antiparticle. In other words, instead of having a twin with opposite properties, like the electron and the positron, the Majorana particle would be perfectly symmetrical to itself. Although this particle was theorized almost a century ago, no one had ever managed to observe it directly. However, in recent years, some experiments have suggested that it might emerge under certain conditions in topological materials. And here lies the great promise of Majorana 1. By harnessing this new form of matter, Microsoft claims to have created qubits that are incredibly stable and less prone to errors compared to those used so far in quantum computers. But is this truly a revolution? Or is it just a well-orchestrated marketing strategy? The scientific community has received the announcement with great curiosity, but also a fair amount of skepticism. The reason is simple. There is still a lack of complete experimental data proving the actual effectiveness of this technology. Furthermore, some physicists have questioned the very definition of a new state of matter. Topological matter is not a new concept, and while it has extraordinary properties, some experts believe that Microsoft is using deliberately spectacular language to attract attention. Let's not forget the competitive landscape. A few months ago, Google announced Willow, a quantum processor with over 100 qubits that demonstrated the ability to perform complex calculations in times unimaginable for classical computers. It is not hard to imagine that Microsoft wanted to respond with something equally impressive, leveraging the aura of mystery surrounding Majorana's name and quantum physics. Beyond the competition between tech giants, it is undeniable that we are at a crucial moment for the development of quantum computers. If Majorana 1 lives up to its promises, it could pave the way for incredible advancements in many fields, from chemistry, with the simulation of new molecules for revolutionary drugs, to cybersecurity, with virtually unbreakable encryption systems, and even artificial intelligence, which could benefit from unprecedented computing power. The implications of such a technology in the medical field are enormous. The ability to simulate molecular behavior on a quantum scale could lead to the discovery of new drugs and treatments at an unprecedented speed. Today, the process of developing a drug requires years of research and testing, but with quantum computers, chemical interactions could be predicted instantly, drastically reducing experimentation times and cutting costs. The financial and economic sector could also be radically transformed. Financial prediction algorithms could process amounts of data unimaginable for traditional computers, allowing market trends to be identified with unparalleled accuracy. This could usher in a new era of risk management, improving investment efficiency and reducing global economic crises. We must not forget the impact on cybersecurity. With the advent of quantum computers, traditional encryption methods would become obsolete. However, the same technology could be used to create new impenetrable security protocols based on the laws of quantum mechanics. This would be a historic leap in the protection of personal data and sensitive communications, especially in an era where cybersecurity has become an absolute priority. But the road ahead is still long. The transition from laboratories to large-scale production is anything but simple, and research on quantum computers is still evolving. For now, Microsoft's promised future remains a fascinating possibility, but not yet a certainty. If Majorana 1 truly works as promised, it could represent a quantum leap in the science of information. But until then, it remains an intriguing enigma suspended between innovation and speculation. Thanks for watching. Leave a like and subscribe to the channel so you don't miss upcoming videos.